Imagine a world where millions of lines of C and C++ code just vanish.
Right.
We're talking about one of the biggest tech giants trying to wipe out decades of legacy code.
And that transition isn't just a thought experiment anymore. It's a real industrial scale bet on AI transforming engineering itself.
Welcome to the deep dive. You shared some really crucial material here, looking at the future of code, the automation of our daily work, and maybe most importantly, how researchers are trying to fix what's broken in AI safety.
Yeah, we're going to break this down. First, that massive plan to eliminate C and C++ code.
Then we'll get into the specifics, the habits that separate a casual AI user from, a true AI native professional.
And finally, we'll dive into a really serious research breakthrough, Anthropic's Bloom framework. It's designed to test if AI models are actually safe, or if they're just good at memorizing test answers.
Okay, let's get into it.
Let's do it.
So this first headline is pretty intense. Microsoft wants to wipe out all C and C++ code by 2030. I mean, that sounds almost impossible given how fundamental that code is to everything.
It does sound like sci-fi, but the engineer leading it, Galen Hunt, confirmed it's a systematic research effort, and the motivation is, well, it's security.
Right.
We all know that C and C++ are where most of the dangerous memory safety bugs come from.
Yeah.
So they're pushing Rust into places like Azure and even the Windows kernel.
Okay, so this is where it gets really interesting for me. This isn't just asking a large language model to, refactor this code. It's much deeper.
Correct. Microsoft built two different layers of infrastructure to make this work at scale. You've got the algorithmic code infrastructure and then the AI-driven code transformation layer.
So what's the difference? How does that work?
Think of it like this. The algorithmic layer handles all the grunt work.
The syntax, the rules.
Exactly. It knows how to parse C++ functions, identify variables, all the formal logic. But the AI-driven layer, that's the intelligence. It figures out what the programmer intended to do, looks at the context, and then determines how to express that same behavior safely in the new language, like Rust. And they're already using this system today for code understanding problems.
So there was this rumor going around that they were going to rewrite all of Windows in Rust. Hunt had to clarify that, didn't he?
He did, yeah. The headline got a little ahead of the reality. The goal isn't necessarily to rewrite all of Windows by 2030.
Right.
The real goal is making language-to-language migration possible at an industrial scale for any language. Rust is just the best test case for this experiment right now.
So if this tech works, what's the next big engineering challenge that pops up?
It becomes all about testing. They'll need robust frameworks to ensure the migrated code isn't just working, but is actually safer.
Testing has to match the scale of the transformation. Okay, so let's flip the coin. We go from these huge institutional shifts to the individual user. You flagged a few things here on how to level up from being, say, AI curious to truly AI native.
Right, there's a distinct methodology people are starting to use. We saw mentions of the 3 habits that separate AI native professionals. It's not about the tool, it's the approach.
And what's one of those habits? What defines that approach?
The big one is moving beyond simple prompts to something called prompt chaining.
Okay.
An AI native user designs these complex, multi-step workflows. They get the AI to do task 1, then automatically feed that output into task 2, and so on. It's like delegating a whole project, not just asking one question.
And that kind of thinking translates directly to business, right? We saw that piece on 8 game-changing marketing trends for 2026. Our current tactics are apparently losing traffic.
Yeah, and it's because of something called zero-click issues.
Explain that.
It's when you search for something, and the AI just gives you the answer right there on the results page. You never have to click through to a website.
So all that work on SEO,
it becomes less effective. The new strategy is to be the source inside the AI's answer. It's also changing the coder's job. We're seeing this shift away from just writing code to managing AI agents that do the building, testing, and shipping themselves.
so the human becomes the manager, the orchestrator.
Strategy over syntax, that's the idea.
And to see how much faith is being put in this, ByteDance, TikTok's owner, is planning to spend $23 billion on AI infrastructure in 2026.
$23 billion.
Yeah, despite export controls. It's a huge vote of confidence.
Whoa. Just imagine scaling that. The data centers you'd need.
Just massive.
That kind of spending just shows that global leadership in AI is the ultimate goal here.
And then you have these grand visions, like Sam Altman predicting that in 10 years, college grads will have some completely new, exciting, super well-paid job. in space.
It's a wild level of optimism.
But you can see how the technology is forcing job roles to just evolve into things we can't even name yet.
So how critical is it for a professional to master this new AI agent management style right now?
I'd say it's vital. You have to focus on strategy, not just syntax.
Strategy becomes the currency.
Yeah.
Okay, so let's get practical for everyone listening. The resources you shared had this beginner's daily AI plan. It's all about automation, turning boring daily work into background tasks.
This is where it stops being a cool toy and starts being genuinely useful.
Right. It's the difference between asking AI to summarize one email versus setting up a system that summarizes all incoming client reports and drops them in a Slack channel for you every morning.
That frees up a huge amount of time.
Exactly. Repetitive things like sending emails, scheduling meetings, generating reports, they can all be automated. It's all about this trigger action model. When X happens, AI automatically does Y.
And part of this is understanding the tools, right?
Yeah.
Like the difference between the two big players, Zapier and Make. Why is that distinction so important?
Because it really impacts your scalability and how complex your automations can get.
Okay.
Zapier is known for being super simple. Linear workflows. You need app A to talk to app B. It's great for that.
And
Make, which used to be called Integromat, lets you build more complex branching workflows. You can have multiple decision paths and more elaborate scenarios.
So Zapier is for a simple two-step process, but Make lets you build like a whole internal engine.
Exactly. And these resources give you a clear path, how to automate a simple task step by step. And they even give you 12 ready-to-use workflows. It's like stacking Lego blocks of data to build efficiency.
That focus on foundational steps is so important. I still wrestle with prompt drift myself sometimes,
Well,
where the model just kind of forgets the original instructions in a long conversation. So knowing these basic automation steps is key for stability.
and it builds confidence. If you're struggling with complex instructions for an LLM, mastering simple automation is the next logical step.
So why is understanding that Zapier versus Make difference so important for new automators?
Choosing the right platform impacts your scalability and complexity down the line. A lot.
Got it. Choose your foundation wisely.
Right. Now, as we scale all this up, the code migration, the personal AI agent's safety becomes critical. We have to ensure these models behave responsibly. And this brings us to Anthropic's open-sourced Bloom framework.
What's so fascinating here is that Bloom addresses this huge kind of silent flaw in how we test AI right now.
It really does. Today's benchmarks rely on static prompt tests, the same canned questions used over and over again.
And the problem is those prompts eventually leak into the training data.
Exactly. So the new models learn how to pass the test, not the actual safety principles behind it. Scores go up, but the real safety understanding doesn't improve. It's just memorization.
That's a huge liability. You're basically deploying systems that have learned to cheat on their safety exams.
Totally. So how does Bloom fix this memorization problem?
Well, it shifts the focus. Instead of testing fixed prompts, it tests the underlying behavior.
How so?
It keeps the behavior definition constant, like, do not generate instructions for illegal activity. But it continuously generates fresh, new situations that could trigger that behavior. It's a dynamic test, not a static one.
And they use a 4-stage pipeline to do this. There's behavior grounding, scenario generation.
So let's talk about that scenario generation stage. What does it actually do?
That's where it gets clever.
Huh.
It's another AI whose entire job is to invent thousands of new, challenging, multi-turn conversations. So instead of a simple question, it might create a complex social engineering dialogue to try and trick the model.
So the score you get actually reflects robustness against new attacks, not just memorization.
Exactly. And by the end, it's not a simple pass or fail. Bloom tracks how reliably a behavior shows up. The result is a detailed behavioral profile, not just a checkbox. It gives engineers a much clearer picture of the model's actual risk.
So what impact does this better evaluation have on all the new tools we're seeing, like generative video or agents that need reliable voice controls?
Well, responsible adoption depends entirely on these safety frameworks. You can't deploy powerful tools into the world if you can't trust the behavioral profile of the model underneath.
Right.
So if AI evaluation shifts to these behavioral profiles, how does that change how models are reported on and sold?
It means transparency will have to focus on reliability across all kinds of different scenarios, not just passing a simple test.
Moving away from easily gained benchmark scores.
So what does this all mean for you? We've seen the sheer scale of ambition, with Microsoft betting on AI to dismantle its own programming past by 2030.
We also saw the rapid professional evolution that's needed, where managing AI agents is replacing writing code. The path to becoming AI native is all about strategy and orchestration.
And all of this incredible power is being supported by crucial safety research. The core takeaway, really, is that the AI frontier isn't just about speed and new tools.
It's equally about the foundational work like the Bloom framework to make sure our systems aren't just scoring high, but are actually operating safely and reliably.
Yeah, in the real world.
Our deep dive today covered everything from these massive institutional shifts like ByteDance's huge infrastructure investment to the really actionable individual tool sets, like knowing when to use Zapier versus Make.
So think about which of your daily repetitive tasks could be immediately shifted to automation. Free up that mental bandwidth for the bigger picture, for that strategy work.
But here's a final provocative thought for you to mull over.
Okay.
If AI agents become responsible for building, testing, and shipping the majority of new software, what becomes the single most valuable skill a human programmer has?
That is a great question. Thank you for sharing your sources with us for this deep dive.
My pleasure.
Until next time.